Hiya guys, and welcome back to Wade's Workshop. I told you I wouldn't be long, didn't I? I had plenty of footage in the can, so we had the opportunity to produce another video. And this is part 2 of the Stuart S50 stationary engine. So yeah, there wasn't a great deal of machining other than a bit of drilling and setting up in part 1. For part 2, we're going to get on with the machining of the base or sole plate casting. So let's get on with it. I've just had a quick look at the drawing, and it gives from the base, which we haven't machined, a centre height of this hole of 1 inch and 15/16. 1/4 inch hole. As it happens, this feature measures at its sort of, as you can see there's a draft on it, but at its centre of that hole measures 1/2 inch. So from that top sort of intersection there, that height would be 1/4 inch down. And then everything else dimensionally has to follow into it. So I'm going to see what the actual height is going to be to look right through the centre of these bearing caps. And then machine the other 2 steps, which is the top of these and the top of these, in the same, with an offset relevant to what this actual dimension is going to be. I mean, I could machine off the bottom to make it. It is actually a little bit out. So what I'm going to do, I've got a 12mm dowel pin in here. I'm just going to come somewhere near. Let me just lock that off. I'm going to eyeball it onto the top. Up a little. Let me just eyeball that. Up a little more. That's dead in line with the top of that feature. So I'm going to set some zeros there. I don't know if I got... in fact, I think what I need to do is use my quill arrow. I think I'll come down, do it with a Z. Just set that again. There. That's the point there. So I'm only using this as a flat surface, but that's dead flush with the top of that feature. Now, I've got to come down according to the drawing. It's a 1/4 inch hole. And it's got to be in the middle of that 1/2 inch wide feature. So 1/4 inch down, that's a 1/2 inch radius, 1/4 inch down. Should be smack in the middle of that. So, just change my DRO to inches and set a 0. And I'm just going to come down 250 thou, see what that looks like. 1/4 inch. 0 that. So that would be the centre line, or the base of this pin would be the centre line of where it would be bored out. So what I want to do now is actually measure what that height is off the base. So I'm hoping I've got enough room on my quill. I probably haven't. Okay. I'm going to 0 the Z on my headstock. And I'm going to wind down 1 inch. So I'm going to change to Imperial. There we go. Get out in the open somewhere. Can't quite reach that. There we go. Somewhere where I can touch. Just winding the head down till I get a friction fit on that rule. There we go. So I know I'm very close. This should be about 40 thou. Hold on. 39 thou, something like that. Just pop a cigarette paper under there. Just gently winding down, a couple of thou at a time. Up there, grip the paper. Let me just have a look. 1.938 inches. I'm going to write that down. 1.938 is where the centre should be to line up from the base. Let's see how that figures in relation to an inch and 15/16. Gone to the Zeus book, and 15/16 is 937.5 thou. So I'm half a thou out, well, doing it by eye. So basically, that tells me that the centre height, let me just bring her up out the way. Bring her up out the way again. Yeah, it basically tells me that the centre height of that hole is smack onto the base as it stands at the moment. So no alterations to do. So that's good. So inch and 15/16 up from the base will give me smack on where that hole's got to go. So that means that these can be on nominal as well, the other two heights. Can you see where I'm pointing? Yeah, you can. These can be on nominal, and will be bob on, so that when the feature here is done, it's going to look right in the caps. Because I can obviously play with these, take a little bit more, a little bit less to bring these into centre, but that centre looks good. So happy days, really. There was nothing to machine off the bottom. I'm glad I didn't, because that would have meant adjusting. So yeah, as I measured earlier, from nominal there was a 16th to come off here, and from nominal there was 0 to come off as a step, so that means 16th off there, 16th off there would be right. So what I do now is I'll come up here, or I'll come to this reference point here where I touched off, or stay on this reference point. I'll bring a milling cutter down to touch on base, and then I'll go back up by the 1.5 inch and deck this off. So I'm using an 8mm cutter. Got that paper in there again. Gradually bring down the Z-axis. Actually, I'm going to lock that quill where it is. I'm going to do all this using the Z-axis. Keep going. Oh, in the way. Yeah, keep going till I feel a grip. And I'm going to do this with every one of the settings I do, so that I'm always using this grip point on the paper as a reference. There we go. Alright, I'm going to set Z-axis quill to 0. And take the quill back up. Oh, too fast. Okay. I've got the lock off of it, yes. Okay. So, first cut is going to be at a height of 1.5 inches. So the surface here of this platform, which is where the cylinder is going to bolt on, is going to be 1.5 inches up from that base. So let's have a look, see if I can get a touch off, see what the crack is. So let's have a look. See where I am now, as to whether I can get under the skin in one go. There's a touch. 38 thou. 1.538 according to my DRO. So I'm going to take a 10 thou and be done with it. The 528, 527. I'm going to climb mill around the outside, but I've got 10 thou cut. I think I'm going to use a power feed. quite see if I'm under the skin. I am. I'm just going to traverse across there, and I'm cutting in the direction inward into the casting. So I'm theoretically climb milling on the edge, so I'm pushing any edge in towards the casting. So I'm going clockwise around the perimeter. Let me come to a halfway mark. Let's go in Y. Okay, swap directions. As you can see, the cutter is cutting into the casting, reducing any risk of a breakout. Left a little touch in the middle. Back to the center. Back the other way. So yeah, first machining job, particularly on the casting. Okay, let's come over and have a crack at this while we're at it. Again, I'm going to go clockwise around this. Don't think I really need the feed for this, but I will. Just for the first bit, maybe. Going around the perimeter by hand. Okay, so let's come down in Z now. Take another 10, I think. 510 we'll leave it at. Okay. Back across here. Back on with the feed this time, I think. So yeah, we're just scratching away. Tenth out of the time. I got under the skin with the first 10. It's a really nice finish on there. Really good bit of casting. That's the second 10. Should we do 2 5-out passes to finish it? Why not? Okay, let's just come off the edge. And let's take it to a 1505 or maybe 4. Okay. What's my cutter running at? A little bit slow actually. 900. It was about 750. That looks good. No, not touching that middle bit. Again, we'll come across, take it up here, and then I'll bring it back when we get the finishing cut. I've dropped it down to 1.5 inches, and off to go, finishing cut. Just back and forth across that to get it in one. I could have probably used a larger cutter, but I didn't want to risk breaking out any edges on the casting. Let that run off. Okay, and we'll just deck this. So I'm going to set a 0 here. Okay. Come out of the way. So I'm going to set a 0 on my Z-axis there and come up by the required 2164. I'll just work out what that is as a decimal. So the figure is 0.3281. So I've just re-zeroed off this that I've just machined. Oh, got my Z-axis locked. 3281, let's go something like 360. We'll have a look, see where we are. Oh, just touching. Okay. So let's I'll do this under feed as well. I'll take it a bit more gentle this time. I will deck it as one. I'll run the cutter in the centre. So we're down to 0.338. It's about 10th out to come off. We'll let that one run its course. Jump across to the other one. Let it run up the end. And back the other way. So that's going to give us a known height, correct there. The relationship to that one, correct. And if this is bored at the height of 1 inch and 15/16 as per drawing, everything is as per drawing. So yeah, happy days. So I'm just running the final pass across top now at 0.3281. Well, 0.32815, but yeah, we're not going to be worried about that 5. So you can hear the cutter running. It's the final cut. And that's those two heights pretty much done. So we have a bit of a setup. One of my new 246 blocks clamped down onto the table. Fortunately, the 12mm studs and T-nuts and clamp kit that I've got will fit through the holes with more than big enough. So I think there were 16mm holes in here, or thereabouts. So with the aid of a couple of washers, I managed to clamp the 246 block down and clocked it up into position. So I've got the part sat, or we'll call this the part now with its base plate screwed on, sat on a pair of parallels either end and tapped down so I know it's all square. And obviously the machined face that's machined true to the casting is facing down. So I've got a wobble pin here now. It's got a 1/4 inch ball on it. And I'm going to pick up a datum from the point where we established that initial height with a reference to drilling and boring out this hole. So I've got a collection of drills together. Let me just show you where I am. So all the bits and pieces here I'm going to need: the centre drill, the drill I'm going to use for the 5/16 reamer, and I think I've got a 6mm drill here which I'm going to pilot. So it's 6mm. I think it's, let me just get this right, what drill I used. I did have a quick look in the Zeus book. It's a 7.6mm drill. Then I'm going to go in, and I've actually bought 5/16 reamer, brand new one, made in the UK. This it's from Tracy Tools. It's a high-speed steel machine reamer. So we're going to set up. Let me come around. So I'm going to use the wobbler. And I'm just going to hit the tripod with my hand wheel. Move you 2 seconds. There we are. I'm just going to pick up off that reference point there. A little bit faster than that, I think. It's quarter ball. Just going to creep up on this any second now. There she goes. Now I'm going to stop that. I'm going to set a 0 there and I'm going to check it again. So repeat the operation. Just, there we go. And indeed the reading is, well, it's nothing on the DRO. Okay, so I'm happy that I'm on the edge of there. I'm actually going to wind back this way, half of the ball thickness, which is 0.125. Or 125 thou. 125 thou. So an 8. Yeah. So now the centre of the shaft is on the edge of the plate. I'll just reset to 0 in Y. So I now need to move the table back 1 inch and 15/16, which is 1.9375. So I'll just do that. Oh, hold on. Something in the way of my table there. So that's 1.9375. Hold on. That's 0.74, 9.374. I know we're talking nothing here, right? Okay. And lock the table. I'm a little bit out. 9.9375. Okay, so that's locked. I think I'm actually going to 0 my DRO now on the centre point there again. So I'll do that. Right, okay. So now I'm on a theoretical centre from the base to the hole in the part. Okay, so what I'm going to do now, I've got a 12mm pin in here. And obviously we're all offset, we're all way off centre. So I'm just going to wind my X and eyeball the centre of that feature in the casting. That looks good there. Let me just bring him down a little tiny bit. Okay, so that would be the centre point, or where the hole is drilled. So I'll just set a 0 in my X. And I'm going to make sure my eyes aren't playing tricks on me. I'm going to come back and try that again. And see if I get something similar within a thou or two. Let me just come down a touch. Yeah, a little bit more to the... A little bit more this way. Okay, that looks... Maybe a little more. That looks about right. And I'll spin you up to the DRO. Don't want to make you dizzy here. Where are we? Okay. So in X, well, I'm 1.7 thou. Now 1.8 thou. So yeah, I don't think we're very far away. I'm just making sure that my eyes weren't playing tricks on me, but that's a fairly good centre on there. So theoretically, we're now looking down on this point, smack on in the middle of what's going to be the crankshaft. 1 inch and 15/16 up, and smack in the middle of this feature. So I'm just going to double check now the casting. So everything is referenced off this centre line, as you can see, going up into the plan view. And what I've got is 5 7/16 to the centre of this boss. So I'm just going to come across with the cutter, with this pin, and just see how that looks for centralised, just as a double check for myself. So we're going to move across in X, 5 7/16, this figure here. So all my zeros are set. I can come away from this and come back to it, no problem. So let's go 5 7/16. I know it's 7/16. You know what? I'm so out of practice. It's 400 and something, so I expect 7/16. What's that? You're all shouting at me now, I suppose. Just under ½ inch, so we'll be in this zone somewhere. Come on, where are you? .4375. So 5.4375. There. No, that's 4.4375. Hold on. I really should clean up my bench a bit more. I've got very little room. And I've got my bread box on the end here. There we are. That should give me a bit more room. Right, okay. Which is getting in my way. .4375. There. So I'm just going to bring that down now. May have to wind my head down a little. And just scan across to see if that boss is in line. And it looks spot on. So, yeah, I'm looking through across the 12mm pin onto this boss, which is about the same size, maybe 10mm, and it's in the middle. So, as far as distances, when everything works out from this centre, I'm sure we're going to be happy days and hunky-dory. So, centre drill up. What speed we doing? Doesn't look out of the ballpark. Just a quick visual around. Yes, that looks good. X and Y set to 0. And point of no return. Let me just get a little brush. I think I need to get a new little brush. I think this is probably the most expensive part of the casting kit, so this is the bit we don't mess up. Not that we mess up, and if we do, we'll find a way around it. There we go. A little bit more. Okay, there's a generous centre drill in the end of there. So swap out now for, I think, 6mm drill. We'll pre-drill it with a 6mm. So 6mm drill. Right through. That's broken through, and carry on down, just gently to start it. Okay. Being very careful on the breakthrough. Lovely sharp cobalt drill, this one. And that's it, we're right through the both. So here we are. No going back now. So change that drill over now for the pilot drill for the reamer. So pilot drill for the reamer's in. Let me just check what it was. 7.6mm. Just slow that down a touch. Now the drawing calls for 1/4 inch. I'm going to put some bronze bushes in that are 5/16 diameter. Okay, up with the reamer next. So 5/16 reamer. What am I running at? 250 RPM. Brand spanking new one, as I said earlier. And there we go, that's through. I think that's about it for this setup as we stand. I've always got that datum because I can put a 5/16 pin in there, so I can come back to that at any time. I think I may need to do a little bit of machining on the outsides of these two to bring it into nominal thickness. The inside is already oversized. I think it was 9/16. It's already more than that in the centre. So I won't need to do any machining in there. I don't think there's anything running on it, but I will check the drawing. But I may need to machine this face here at some point going forward. It'd be nice to have I believe that I think there's a washer sits on here behind the flywheel. And it'd be nice if that washer was on a flat surface rather than this inclined surface. So I would like to put something like maybe a 16mm radius or something to clear the washer to square that up. But what I'm going to do is put it back down flat and find out all the centres, and we'll go from there. I've been having some fun and games here. I was trying to set up a reference or a datum in this plane, or in Y. As you see, I've got it set back up, squared up against my 246 block, clamped down on some parallels and back hard against the machine face against the 246 block. So I've got that plane of the two holes at 90 degrees. We've already set the heights of the 3 height levels. But I wanted to sort of define some hole positions and what have you for the holes out here. So I looked at this dimension here, and it is oversized. And the outside is oversized as well. So this material could be taken off the outsides, both sides. But I thought I'll pick up the centre. So I did, with the old little wobbler, picked up the centre here. Set a 0 on my datum. So I found, the theoretical centre. Moved over the correct amount, which should have been the centre of this, of these two guide bars. And then offset both ways. And my holes were actually about 1 mil too far back. So went looking for something else I could use. So what I did, I picked up the centre of the outsides of the two rails here, and then stepped back to what would be this space. And it turns out that there's 7 thou left on this back face here. Overall, let me just have a quick look. This dimension here, at the centre where the holes are, 1.282, and I believe the drawing shows that width as 1.2188, 1.219. So it's about 60 thou to come off. So with a 7 off that back, there's going to be about 50 thou to come off this space. It is hidden behind the flywheel. There's a washer goes on here. So, yeah, if it's going to be out, it's this face here is a little far out in relation to the back. The back's good to the rails. The inside's oversized anyway, and this is way over thickness. So I think what I'm going to do is run from the centre of these rails here and set everything up distance-wise in Y as we're looking at it, based on the centre line of these rails, which again, wobble pin both sides gives you a 0, and we'll go from there. So there is a set length for these rails, distance from the centre for the ends of the rail. So I think what I'll do is I'm just going to pop the reamer and the shank of the reamer does fit in there. So I'm going to pick up both sides of the reamer. I'll have to get an edge finder for that because we got a round surface on a round surface. Not much good for picking up a centre. But I'll pick up a centre of this reamer, and at least that gives me a X datum for the centre line of the ball that we just drilled. And then I can start machining the outsides of these bars here to get us back in. Well, there we are, guys. I think as a midweek video, I think we're sort of 36 to 40 minutes long. So quite a video for a midweek one. I've done loads more work on the project, so there's certainly going to be enough footage already in the can to put up next weekend. So, yeah, I'm running probably 3 or 4 days ahead of what I'm putting up at the moment. So, anyway, guys, that's enough for today. Thanks for watching. Thanks very much for subscribing, and we shall see you all very soon. Cheers now.